Hello everyone. Let us see today how to draw the parabola using the eccentricity method. So, looking at the question given, draw the locus of a point P moving in such a way that the ratio of its distance from a fixed point to a fixed straight line is always constant and is equal to 1. So, equal to 1, so eccentricity is equal to 1. The distance between the fixed point and the fixed straight line is 65 mm. So, if we are drawing a straight line, and what we are drawing is a rough sketch. This is the focus, which we call as a fixed point. This is the directrix, DD dash, which is a fixed straight line. And he's asking us to name the curve. So if eccentricity is equal to 1, the curve is parabola, right? So he's asking us to draw a parabola which is passing through a point P, and the distance is given as 65. So this is your question. And this is your transverse axis of the parabola AB, and this is your vertex V, such that these two sides are equal, VF equal to VE. So this is how we are going to draw the rough sketch. Let's just go to AutoCAD and check out how do we do in the AutoCAD. So first step, what is the first step you're going to do is the eccentricity method. It is similar to your what you have done in the ellipse. If you have not watched the ellipse video, please do watch it. So this is the directrix. Now P type for the point we are taking. I'm considering the P type. And now I'm drawing the offset of 65. So this is the offset distance, and I'm marking the point at this place. This is your focus. So let me give the nomenclature for this. Text, enter, 0, enter. So this is your directrix D, D dash. This is your axis A, B, and this is your focus. So we can edit the text later, but right now I'm preferring to move it. And this is the point. So what I am doing next, divide, select this object into two equal parts. So this is your vertex V. The vertex. So next step, what I will do, I will take a line from the vertex, okay, which is perpendicular to the axis, and draw a circle from vertex to point F. Now this is your E point. So I will name this point as point E. Okay, so this is my point of intersection. Trim the unnecessary part. Next step, what I will do, I will join the line A to E and keep it. After this, extend this line to further. So next step, what I am doing, I am drawing arbitrary lines. In OSNAP, I can keep the nearest on. So I'm taking this, I'm drawing this line. So this is 1 dash. I'm naming this line as 1 dash. So once I name it, I'll take a circle. The radius is 1 dash, but the center I have to move it to the focus. So it will intersect 1 dash somewhere. So I am marking that point P there. So this is the point P, intersection point. Second step, I'm taking this line further and naming this second one as 2, 2 dash, escape, 2, 2 dash, next. Move this circle to 2, drag it to the radius of 2, 2 dash, and the center must be focus always. So move it to the focus. It will intersect 2, 2 dash at a point. So that is 2, 2 dash. So next, trim it. So next step, what I will do, I will take another line, 3, 3 dash. So this is a circle I am drawing. Move the center to point F. So that's your point E3. So like this, these need not be equidistant. I can delete the circle later. Next, circle with 4, 4 dash is radius. Move this center to the focus F. F is a focus, please don't forget it. This is the center, I can delete the circle. Next step, I can continue this process. Circle, nomenclature, once you understand it, it is easy. Next, go to the point, specify the point and delete the circle. So let us go to the text, single line text. So this is your point 3, 3 dash, 4 dash. I have taken approximately 5 points, which are enough. 4, I can just move them to a single line. So this focus to the focus point with no confusion. So next is go to the text, single line text, right click. So this is your point P1, this is your point P2, P3, P4, P5, enter. So now what I will do, I will take a mirror image of these points, 1, 2, 3, 4, 5, and these lines on the other side. In the nomenclature as well. Right click first point on the mirror line because it is the same. No. So these are the points on the other side of the parabola. So AutoCAD offers you very nice opportunity to do the mirror image. Once done, go to draw, take the spline curve, join through the points. Vertex is 1 point. Please don't forget. And right click, enter. So this is your parabola. So select the spline, use P-edit command, select the spline, right click, enter, give the width 0.5 mm. So that's your spline, 1.0. So I just gave the width as 1.0 and this is your parabola with 5 points. The next step what he asked is draw the tangent and normal at a point. At any point if I am taking, I am considering an offset distance of 85 from the, let me take a different color for our understanding. So I'm taking an offset 85, enter from the directrix. So this is your line. So I can choose a point on the either side. So I am choosing the point on the curve to be this intersection point. Okay. So now what is the next step I'll do? Once I have chosen this point, I'll go to line, enter, join this to the focus. Okay. So I'm joining the point to the focus and this line I'm rotating it by rotate by this point, copy it and rotate it by 90 degrees. So it is intersecting the directrix at a point and this is your the point, right? So that is your tangent point, one tangent point. So I will just name it. So this is the tangent P and this is your point P. Okay. So next step what I will do, I will take this tangent and join to P and extend it to further. So till where it can go, let's extend it. Next step, select this, use the rotate command and use this point as one, copy, reference and 90 degrees. So this is your normal. Rotate the line. Now trim off all the extra parts. Okay. So when you are going with a single line text, just give N, N dash. It is the normal. Afterwards, what is the next step? Go to P-edit command, select the normal, select multiple, select the tangent, select the normal, right click, enter, and the width, give it as 1.0. So this is your tangent and normal. So once you have drawn the tangent and normal, that is the end of this. So what is the next step I have to do? I have to give the dimensions. So dimensions, I'm choosing a different color just for understanding. What all dimensions you have to give? You have to give the distance between the directrix and the focus. That's it. And you are giving the distance between this and the point. Nothing else is mentioned, right? So in the question, he clearly asked you, name the curve. Therefore, I will use the single line text and I will name the curve, parabola. Enter. Once I name it, I can change the height later. So this is your parabolic curve. I hope you understand this easily. And with this, I'm stopping my parabola. Any doubts, you can ping me. Oh, దేవుడా. Oh, how it's recorded. Why so? I recorded it right.